Hello everyone. So we are back again today with the new topic of second law of thermodynamics, and I welcome you to the India's most comprehensive preparation platform for GATE and ESC, BYJU'S exam prep. Okay, we are together for this is the fourth day. We started with the questions. It's a learn through question series. Okay, it's a learn through question series. So we started with work and heat, and we gave a fair time for first law of thermodynamics, because first law of thermodynamics is a fairly complicated topic. Okay, and it covers major portion of thermodynamics as well. Today we'll move ahead with the second law of thermodynamics. Now I know that last 3 days we have solved very nice questions. Okay, we started with the basics and we have gone through advanced level. Okay, I have also solved some ESC conventional questions with you, and I hope you are all comfortable with this. Now if my audio and my video is clear, could you please tell me, are you able to hear me? So we can start very soon. Okay, Bhavya, welcome today again. So let's move ahead. A brief introduction. I have around 4 years of industry teaching experience. My MTech is from IIT Kharagpur and also MSc from Politecnico di Milano. Some industry experience, research experience, and some research publications as well, international and national as well. Sachin, good evening. Welcome to the session. And we are doing thermodynamics, but very soon you will also see me doing other subjects as well. Okay, here only on YouTube, BYJU'S exam prep, and also in app. Okay, very quickly let's move ahead. This is everything, every day's thing. Okay, anyway, so I gave you this question yesterday. I hope you have tried to solve it. Okay, this was the question, steady flow question. This was steady flow question. Did you try it, Bhavya, Sachin? Work was 70.84 kilowatt. Let me check. Work is not 70. I'm sorry. There is some mistake that you have done. I don't know what mistake you have done. It's not minus. I don't know how you, but Sachin, good that the answer is correct. I don't know how you got minus. It's not minus. Okay, you try. Okay, it could be minus because you calculated work output, isn't it? That is true. You calculated work output, so it is minus 104.4 kilowatt. I calculated work input, so for me it was plus. Yes, that is correct. Sachin, Bhavya, what was the issue? What is the problem? Why were you not able to solve it? What mistake did you do? Sachin, that answer is correct. 104.4. Very nice. You know, okay, just I'll very quickly give you the idea, so you try it again. Because area you can calculate. I don't think inlet and outlet area is an issue. Work could be an issue. Very quickly I'll tell you what you can do. So you write the steady flow energy equation. Steady flow energy equation. What was that? M dot H1 plus V1 square by 2 plus Q in is equals to M dot H2 plus V2 square by 2 plus work output. Okay. Now they are saying the internal energy is given of the air leaving is 88 kilojoule per kg greater than that of the air entering. So U2 is U1 plus 88 kilojoule per kg. What is exiting, its internal energy is 88 kilojoule per kg greater than what was entering. Okay, so U2 minus U1 is 88 kilojoule per kg. Now they are saying absorbs heat from the air at the rate of 59 watts. Okay, so what do we have? Compressor is there, cooling water in the jacket surrounding the cylinder. So we have compressor and there is some cooling jacket that absorbs heat at the rate of 59 volts. So this heat is going out of the compressor. Okay, cooling water in a jacket that is surrounding the compressor cylinder absorbs heat. So what is absorbing heat? Cooling jacket. So that, but how this heat is coming from the compressor? So this is Q out. Okay, so this would be minus 59. Okay, now can I write? I need to find out work output. I need to find out work output. Can I do m dot H1 minus H2 plus V1 square minus V2 square by 2. Velocity is given, right? Yeah, velocity is given. This is 4.5 meter per second. And 6 meter per second. Okay, this is V1 and this is V2. Okay, now what you need to do here, you need to convert this into U1 plus P1 V1 specific volume minus U2 plus P2 V2. Did you try the same way? Plus V1 square minus V2 square by 2. You know everything. You know everything. Mass flow rate. You just have to put the values, okay? So what you can do? You just need to put the values. Is it the same way you tried? You know U2 minus U1. You know P1 specific volume V1. P2 also you know. Everything is given. This is P1. Put it in. It is in bars. So how will you put it? So it says P1 is equals to 1 bar. So you will put 1 into 10 to the power 2 kilopascal. P2 is 6.9 into 10 to the power 2 kilopascal. So everything, specific volume is also given. This is specific volume 1 and this is specific volume 2. CPT and U is given. No, U is given. No, this is given. Internal energy is given. The internal energy of the air leaving is 88 kilojoule per kg greater than that of the air leaving. CPT and U is given. U is given, right? Did you put CPT in this? You don't know temperatures. How did you use CPT? temperatures you don't know, then how did you use CPT? Yeah, but temperature you do not know, right? P specific volume by R. That is PV is equals to RT. So from here you can calculate T1. Now specific volume you know, R also you know, it is air. Pressure P1 and P2 also you know. So yeah, I think it should come according to that. Then why it did not come? It should come. If you know R, either they are not taking CP values correctly. It is air, so we know CP and R values, right? You know pressure, you know specific volume, you know R, temperature can be calculated, yes. So it can be done like that. I don't know why you did not get the answer. The way is correct. There is no doubt that you tried an unconventional way, because internal energy was given. So the idea was to use internal energy, okay? Okay. I do have Telegram channel, okay, but I don't know it. They are, I mean, they still have to give me the name. But you can comment here. You can comment in, I mean, after the class, you can comment in the same video. Then maybe I can share it with you, okay? But I would say the method is not correct. The method is correct. I would have to check why you did not get the answer. I need to solve it this way, okay? The method is absolutely correct. But the idea was to use internal energy because it was given in the question, okay? But the method is right what you tried. Anyway, let's quickly, very quickly, let's move ahead. We have, okay, this question. Have you tried this question? Sachin, are you there? Did you try this as well? Mass entering is 4.6. Yes, that is correct. 4.9 I got. I think that is also correct. kg. So Sachin, did you try it? Then very quickly we'll move ahead. Sachin, could you please tell me, or I should solve it here for you? But we cannot understand it. Why did you know? Why were you not able to? You did not understand the question. You did not. Okay, so basically what we have an insulated tank, okay, and it has some air. It has already some air. That means it has some mass m1, and the pressure is, initial pressure is 0.1 megapascal. And initial temperature is T1 is equals to 300 Kelvin. Okay, now it is some and its volume is fixed. Volume is 1 meter cube. Okay, now it is connected to a high pressure line in which air at 1 megapascal. So some air is coming here. Okay, it entering at pressure P1 1 megapascal, and temperature is equals to T1 is equals to 600 Kelvin. And you fill the tank until the pressure inside the tank here P1 is equals to 1 megapascal. Now I don't know what is T2, but I know that it will, mass will increase. Mass will increase. Yes, okay, I'm going through the process, okay? Okay, so if you remember the equation that we talked about, unsteady flow energy, SFEE. So mass entering M in H in kinetic energy and potential energy I am neglecting, plus Q in is equals to mass that is going out, M out, H out, plus if some work output is obtained, plus change in energy inside the system. Okay, change in energy inside the system. So M2 U2 minus M1 U1. So what I have done here, I have neglected the kinetic and potential energies. I have neglected kinetic and potential energies everywhere. So this equation is left. Now tell me, this is insulated tank. This is insulated tank. So no heat transfer is happening. It is simple filling of tank, no work output is there. Okay, and no exhaust, nothing is going out, no mass is going out, so this is also 0. Now Mi Hi is equals to M2 U2 minus M1 U1, right? Now determine the mass of the air which entered the tank. So what entered into the tank? How much mass entered into the tank? So you tell me one thing, M1 you calculate, right? M1 can be calculated as P1 V1 upon R T1. Everything we know, pressure, temperature, R, and volume is fixed. Volume is fixed. M2, can you calculate M2? P2 V2 P2 V2 R T2. How much M1 did you get, Bhavya? M1 is 1.16. M1, let me check. 1.16, that is correct. 1.161 kg. What is M2? Can you calculate M2? Can you calculate M2? Sachin, did you try this? Is this the way you tried? Very quickly we'll move ahead, okay? I have to solve second law questions as well today. M2, what is M2? M2, basically T2 you don't know, okay? So this will come in the form of T2. It is around, how much is it? P2 is 1 megapascal, so 10 to the power 3 into 1 upon 0.287 into T2. Could you please tell me how much is M2? How much is M2? 3484 point, that is correct. I think that is correct. This is 3484 by T2. 3484.32. That is M2. Now what is M entered? How much M is entered? M is entered as M2 minus M1 Hi is equals to M2 U2 minus M1 U1. Now M2 is 3484.32 by T2 into CPTI. CPTI. Okay. What is TI? TI is 600. This is 600. CP is 1.005. CP is 1.005. M2. M2 is 3484.32 by T2 into U2. U2 is what? CV T1. I know T1. I know T1, right? I'm sorry, T2. minus M1 is 1.161 CV T1. T1 is 300. T1 is 300. T2 I don't know. This will get cancelled. This you can calculate and this you can calculate. I'm sorry, I have done a mistake here. Minus M1 1.161 CP Ti is equal to M2 3484.32 by T2 into CV T2 minus M1 I know 1.161 into CV T1. Now the only unknown is T2. How much is T2? Did you calculate T2? Is this how you solved, Bhavya, or did you try any other method? Look, either I have a relationship between M2 and T2. Now in this equation, I have two unknowns, M2 as well as T2. But I know the relationship. CV is 0.718. Look, for air you should know. For air, it says air, right? Air. For air, Cp is equals to 1.005 kilojoule per kg Kelvin. Cp is equals to 0.718. CV is equals to 0.718 kilojoule per kg Kelvin, and R is equals to Cp minus CV 0.287, right? Yeah, CV, how that is also you can calculate. That is how also you can calculate. Okay. T2 is 672. T2 should not be 672. T2 should not be 672. It is 711.8 Kelvin. Some calculation mistake maybe, because the values are fairly simpler. Okay, CV is 0.718. Look, this is 600. Okay, this is also 600. T2 I don't know, so but it will get cancelled. I am not worried about that. This is 300. So then what is the issue? T2 should be, yeah, okay, that's solved already. Okay, you calculate T2, you will get around 711, maybe plus minus 1 or 2 here and there. Okay, 711.8 Kelvin, and then you can put it here and calculate M2. You can calculate M2. Now determine the mass of air which entered the tank. How much mass entered the tank is Mi is equals to M2 minus M1. Now you know M1, you know M2. You can calculate how much mass entered. Okay, let's move ahead very quickly because we have to solve Good number of questions today for second law. Sachin, should we move ahead? Okay. Very quickly tell me this. We will start with very basic question. We will move ahead with some good questions. Okay. Very basic question, should not take more than 2 minutes to solve this. Carnot engine is there. Carnot engine is there. Rejecting heat 800 kilojoule per kg with a thermal efficiency of 60%. How much heat is added to the engine? How much heat is added to the engine? We have a Carnot engine. T higher, Q1, Q2, T lower, work output. Now the heat that is rejected, is 800 kilojoule per kg. So they are saying that efficiency, thermal efficiency is 0.6. 0.6. Yeah, that is correct. Vijaya, that is correct. 2000 kilojoule per kg. Very simple. Nothing is there. 1 minus Q lower upon Q higher. We know this. We know this. Only one unknown. Sachin? Vijaya, yes, that is B. Bhavya, that is correct. So we very quickly will move ahead. We have to solve questions. Okay, we don't have much time. Sachin, we are moving ahead. So QH is equals to 2000 kilojoule per kg. Let's move ahead. Okay, solve this question very quickly. An inventor says that his new concept of an engine, while operating between temperature limits of 27 and 327 degrees Celsius, rejects 40% of the heat absorbed from the source. Okay. Inventor says he has developed a heat engine that operates between 327. How much is 327 in Kelvin? 327, 373, 300, 600, right? 600 Kelvin. This is 600 Kelvin, I think. And this is 300 Kelvin. Q1, Q2, W out. Now this inventor is saying that it rejects 40% of the heat absorbed from the source. So it is saying that if Q1 is 100, then 40% is rejected, means 40 is rejected. C, yes, that is correct, Vijaya. Impossible engine, that is correct. So should I need to solve this? It's very simple question. I mean, I don't think there should be any. Second law questions are simpler than first law questions, okay? Because first law have a lot of concepts. Heat transfer, work transfer, open system, closed system, unsteady flow, steady flow, everything comes there. But as soon as you move ahead, I think entropy has few doubts, but we are going to solve that tomorrow, okay? And if you have followed my entropy sessions, please follow those sessions, okay? They are on YouTube, BYJU'S Exam Prep, GATE channel, okay? You will get a fair idea of what we have to do. Yes, that is correct. T2 was 711. That is correct. Okay. So second law questions are easier than first law questions. First law is the main part, okay? And most of the questions come from there. Anyway, so Sachin, are you able to solve this? So here work output is 60, okay. So the efficiency is Q1 upon W. Q1 is, I'm sorry, W, I'm very sorry. Desired output upon input. Work output upon input is Q1, 60 upon 100. So efficiency of this heat engine is 60%. But if I talk about a reversible heat engine, then it will be 1 minus TL minus TH. 1 minus TL is 300 by 600. 1 minus 0.5, 0.5. So if a reversible engine is working between these temperature limits, maximum efficiency is 50%. Now the inventor is claiming that my engine has an efficiency of 60%. That is not possible. That is because it violates second law, Kelvin-Planck's statement. Okay. So it's an impossible engine. Okay. Let's move ahead. Okay. Can you try this as well? Sachin, that is correct. It is an impossible engine. Okay. Sachin, please increase your speed, okay? Because speed is also important. Accuracy is as much important, but speed is also important. Okay. You cannot take. I mean, for that question, you cannot take more than 2 minutes. You should not take. If you are writing GATE or any exam. Yeah. So we have an engine, 4-stroke bike engine, delivers 80 kilowatt of power. So power, work output or power is 80 kilowatt. So when you talk about power, you put a dot here, okay? It is kilojoule per second power. While consuming fuel at the rate of 60 liter per second. So fuel, mass of fuel, m dot, whenever you talk about per unit time, okay? For example, per unit second, per unit hour. So you put a dot because it is flow rate. It is flow rate. Sachin, it's okay. It's completely fine if it is your first time. But keep trying, okay? There are people who do it in first time, okay? So yeah, that is correct. 14.3, which are very nice. 14.28, Bhavya, very correct. Sachin, should I solve this? So mass flow rate is 60 liter per second. Per hour, I am sorry. Now you need to convert that into kg. You need to convert that into kg because this calorific value is, or heating value is 42,000 kilojoule per kg. So the heat absorbed. So if this is my engine, it is giving you work output. By absorbing heat Q1 and rejecting heat Q2. Now how is this heat coming? By burning of fuel. By burning of fuel. So how do I calculate Q1? Q1 is equals to Q dot 1 is equals to mass flow rate of fuel into calorific value of fuel. Now this is in kilojoule per kg. This is in kilojoule per kg. So I need to calculate mass flow rate of fuel into kg per second. Then only I will get kilojoule per second, which is kilowatt. So this is in kilowatt. I need to calculate this also in kilowatt, and I will put efficiency is equals to W upon Q1. So how do I calculate this mass flow rate? So basically mass density is equals to mass flow rate by volume. Okay. density is equals to mass flow rate by volume. Okay. Mass flow rate is equals to density, which is in kg per meter cube, into volume flow rate in meter cube per second. Okay. Now density is known to me, 800 kg per meter cube. What is volume flow rate? 60 liters per second. 60 liters per second. In meter cube it is 60 by 1000 into, now this is in liters per hour, so I need to convert that into seconds per hour. Okay. Now you will get, I don't know how much mass flow rate of fuel. Yes, I am not sure when, but yes, we will take psychrometry, we will take. Okay, mass flow rate of fuel you can calculate from here. Okay, from here you can calculate. How much is it? $48. I don't know how much is it. Can you calculate it for me? Anyway, Sachin, now I think it should be clear. Okay, I don't know how much is it, but you put it here and you calculate Q1. You put it here and you can calculate efficiency. It's 0.143 or 2, whatever it is. Okay, so let's move ahead then. Is what is this? 1 by 75 kg per second. 800 into 60. Yeah, that is correct. That is 0.0133. Okay. So 0.0133 kg per second. You put it here, you calculate Q1, you put it here. Work is already given to you. W dot is given to you. 80 kilowatt. Okay. Let's move ahead. Yeah, that is correct. Why you people keep so complicated names on YouTube? I don't know how to pronounce that. Vlogs, DT vlogs. Okay, that is correct. Anyway, please put the units also always, okay? So that you will have some idea that what should be the units, okay? 560 is Q1. That is correct. Tarun Tanti, welcome. Okay, so Q1 is 560, that is correct, and efficiency you will get 14. Okay, very quickly let's move ahead to the next question. A reversible engine A absorbs energy from the reservoir at temperature T and T1. A absorbs energy from a reservoir temperature T1 and rejects energy to a reservoir temperature T2. A second engine B absorbs the same amount of energy as rejected by engine A from the same reservoir at temperature T2 and rejects energy to the reservoir at temperature T3. what will be the relationship between T1, T2 and T3 if, so we have a reservoir at temperature T1 and a reversible engine is there that is absorbing heat Q1 from this reservoir. Then we have a reservoir at temperature T2 rejecting heat Q2 and producing work output WA. Now there is one more second engine B absorb the same amount of heat Q2 and rejects at T3 WB. Okay, now they are saying what is the relationship between T1, T2 and T3. Sir, can you please share this PPT for practice again? I can share. Okay, are you following Telegram channels of BYJU'S Exam Prep? If you are following, then I can share it there. I will share my Telegram channel very soon. I don't have it yet. I mean, I've asked them. Okay, so I'll share it there. Okay, I'll share in Telegram. It's a common channel, common group. Okay. Okay. So we have to talk about the relationship between T1, T2 and T3 if the efficiencies of both the engine A and B are the same. Case 1. Case 1. Efficiency A is equals to efficiency B. Okay. And these are reversible engines. These are reversible engines. Okay. So 1 minus Q Q2 by Q1 is equals to 1 minus Q3 by Q2. If it is a reversible engine, I can write 1 minus T2 by T1 is equals to 1 minus T3 by T2. Because for a reversible engine, I can say Q1 by T1 is equals to Q2 by T2. Okay. Only for a reversible engine, I can say this. For Q2 by T2. Okay. T2 is equals to T1 into T3, under root T1 into T3. That is correct. Okay. So this will get cancelled. T2 square is equals to under root T2 square is equals to T1 into T3 and T2 is equals to T1 into T3. So if the efficiencies are same, this is the relationship between T2, T1, T2 and T3. So if in GATE you will get this kind of question and they have given the temperatures, you can directly use this conclusion. You can directly use this conclusion to calculate T2, T1, T3, whatever you want to calculate. Okay. Next is if the work delivered by both the engines is same. So if WA, case second, if WA is equals to WB, WA is equals to WB. Can you solve this and tell me what is WA? WA here, if you do an energy balance, for engine A, then WA is equals to Q1 minus Q2. Similarly, if you do an energy balance for engine B, then you will get WB is equals to Q2 minus Q3. Okay, so let me write it here. Q2 Q1 minus Q2 is equals to Q2 minus Q3. Okay, is this, are you solving it with me? So can I write Q1 plus Q3 is equals to 2Q2? Can I also write Q1 by Q2 plus Q3 by Q2 is equals to 2? Yes, I can. Now for reversible engine A, I can write this. So from here, can I write Q1 by Q2 is equals to T1 by T2? Similarly, for reversible engine 2, I can write Q2 by Q3 is equals to T2 by T3. So by using these equations, I can replace this T1 by T2 plus T3 by T2 is equals to 2, and from here I can determine T2. T2 is equals to T1 plus T3 by 2. So these are conclusions that you can use. Yeah, Bhavya, that is correct. These are conclusions that you can use in your GATE exam directly. Okay, this is from a ESC exam. Okay, engineering services exam, subjective question. But what we know that we can use this conclusion in a GATE exam. If they, and very frequently they ask you this kind of setup. Okay, and you may have to find out WA or something, or temperatures. So now you know the relation that if the efficiency is same, then this is how they are related. If the work is same, then this is how they are related. Okay, let's move ahead very quickly to the second last question of today, and then we will see if we can solve the last question as well. Okay, otherwise you have to solve it for tomorrow. Okay, now just read this question and then we will try to solve it. Okay, now our highs is I'm really sorry. Okay, so our house is there. Our house is to be maintained at 25 degrees Celsius in summer as well as in winter. For this purpose, it is proposed to use a reversible device as a refrigerator in summer and a heat pump in winter. The ambient temperature is 40 degrees Celsius in summer and 3 degrees Celsius in winter. The energy losses as heat from the roof and the walls is estimated to be 5 kilowatts. So Q loss that is happening is 5 kilowatt per degree Celsius. So whatever temperature difference per degree Celsius temperature difference between the room and the ambient condition. So whatever the temperature difference is there between room and the ambient, that much energy is lost. Power we need to calculate to operate this device in summer and winter. Okay, so I hope you are able to understand this question. Okay, let's take case 1, summer case. Okay, so first is summer case. Now what is happening? Look, I have a room. That I have to maintain at 25 degrees Celsius. 25 degrees Celsius. Okay, my surrounding is at 40 degrees Celsius. In summer, in July or August, outside temperature is more, right? and for comfort I have to maintain 25 degrees Celsius. Now because yes, that is correct, Vijaya. Okay, so this type of questions could be, okay, it requires some conceptual understanding. Okay, it's not a directly formula based question, it requires some understanding. Okay, Sachin, are you asking this or are you telling me? Okay, so what is happening? Look, so outside it's 40 degrees Celsius, inside it's 25 degrees Celsius. I want to maintain. Now naturally the heat flows from high temperature to low temperature. So because outside it's 40 degrees Celsius, there will be some heat that will enter into the room. So there will be some heat that will enter into the room, Q. There will be some heat that will enter into the room naturally. Now because of this heat, this temperature is going to increase. This temperature is going to increase. Now if I have to maintain my room at 25 degrees Celsius, then I have to continuously remove this heat. Continuously remove this heat. Okay. So what will I do? How to remove this? I will use a refrigerator. Reversible refrigerator. Okay. It is a reversible device. And I'll continuously remove this heat Q2, which is equals to this Q. Where will I remove this? To surrounding. I have to remove this to surrounding. So because I have to transfer heat from low temperature to high temperature, I have to provide work. I have to provide work. Okay. Now what is this Q? What is this Q? This is given as 5 kilowatt into temperature difference between room and surrounding. What is temperature difference between room and surrounding? Temperature difference between room and surrounding is 15 degree. So this is 75 kilowatt. 5 kilowatt per degree Celsius is there, and this is degree Celsius. Okay, 15 kilowatt. So Q2 now I know Q2. Q2 is equals to 75 kilowatt. Okay. Now I need to calculate power required to operate this device. How do I calculate this? How do you calculate this? Power. COP of refrigerator is what? Desired output upon input. Power is 3.775. Let me check. Yeah, that is correct. That is absolutely correct. Vijay, are you able to solve this? Sachin? Okay. COP of refrigerator is desired output upon input. Now for a refrigerator, what is desired output? It is the temperature that you have to remove. That how to prepare, because I try to solve the questions. Look, you have to start, you are preparing for the first time, I understand that, but there should be a strategy. Okay, if you directly come on the questions without having your concept, without having a good understanding of the concepts, then you will get confused. Okay, so you have to prepare with a good strategy. Okay, you have to make a good strategy from the beginning. First, focus on your concepts, start basic questions, practice as many questions as possible. Okay, do not just focus on theory, because GATE is purely numerical exam. Okay, although there is a whole discussion that can happen on this, but we are running late on time. Okay, so but how How can I help you? Okay, I actually don't know at this point of time, but you keep following. I'll give you my Telegram channel, okay? Then we can discuss this, okay? So let's quickly solve this, and we have last question as well. Desired output is always refrigerator focuses on this heat, because the purpose of refrigerator is to maintain low temperature. The purpose of refrigerator is to maintain low temperature. So the purpose of refrigerator is to remove this heat. The focus is on this heat. So Q2 by W, Q2 by W. Now Q2 by Q1 minus Q2. Okay, Q1 minus Q2. Now you know Q2 this is T2 by T1 minus T2. So you can calculate COP. You can calculate COP, and by calculating COP and this, you can calculate work. Okay. From here you know T2, you know T1 and T2 both. So from you can calculate how much is the COP. How much is COP? $19. Really? Oh, it's really high. Okay, 19.86. That is a really high value. Okay, anyway. So now once you know this, you can use 19.86 is equals to Q2 by W. Q2 you know 75. W you can calculate, okay? W you can calculate. Yeah. So W is 3.776. That is correct. Sachin, it is not 20 because I calculated myself right now. Okay, so maybe you have put something. Okay, maybe you take, what did you take 29? I don't know, it's not 20, okay? Just try it one more time. It's 19. I have calculated it right now. Just now I have calculated it. Okay. Anyway, let's take the winter case. Let's take very quickly the winter case because we are running out of time. Winter case. Okay. So what is happening in winter? I have a room. That I need to maintain at 25 degrees Celsius. Okay. Now the surrounding is at 3 degrees Celsius. Surrounding is at 3 degrees Celsius. Vijay, are you solving this? Did you solve the last question? Last part of it? Okay. Now what is happening? My room, it's a winter case. Okay. It's a December case. What is happening? Outside temperature is low. My room is at 20. I want to maintain it as 25 degrees Celsius. Okay. Now because outside temperature is low and inside temperature is high, so there will always be some heat loss from inside to outside, from the room to the outside surrounding. So there will always be some loss Q. Now because of this temperature will decrease. This temperature will decrease. Now in order to maintain the room temperature constant, I need to provide this heat Q continuously. If I am not providing this heat that is going out, then what will happen? Temperature is not going to remain constant as 25 degrees Celsius. It is going to decrease. Okay, so I need to provide this Q1 is equals to Q. How will I provide this? I will install a heat pump. Now heat pump, if I am installing, where will this heat come from? From the surrounding. Okay, heat pump cannot generate heat. It will come from somewhere, right? So it will come from the surrounding Q2. Again, heat transfer is happening from low temperature to high temperature. So I need to provide work input. So Q1, now I know Q1 is 75, not 75, I am sorry. It is 5 kilowatt per degree Celsius into temperature difference degree Celsius. Temperature difference is how much? 22. 22 is the temperature difference. How much is Q1 then? How much is Q1? Power is 8.21. Yeah, 8.121. That is correct. Okay. Okay. So this is 110 kilowatt. 110 kilowatt. COP of heat pump is equals to Q1 by Wn. Okay, same process. COP is 13. I don't know how much is COP. I hope that is correct. Okay, because only when COP is 13.54, yeah, that should be correct. Okay, so you can write Q1 by Q1 minus Q2, and you can write T1 upon T1 minus T2. You can calculate it as Bhavya has calculated. It is 13.54. So you use this is equals to Q1 I know, Wn I need to calculate. Wn is equals to 110 by 13.54. 8.12. Sachin, are you able to solve this? Sachin, are you there? Is it clear? Yeah, that is 8.12. Absolutely correct. Okay. So let's move ahead. Okay. This is a question. So I don't think we have time for this. It is not a complicated question. Very easy question. Very easy question. Very simple question. And based upon what we have done today, it should not take you more than 10 minutes. Not 10 minutes. 10 minutes is too much. It should not take you 5 to 6 minutes to solve this question. Okay. Just take this question down. Take a screenshot or whatever. Okay. And we can discuss this tomorrow. You have to tell How many statements are correct? A, B, C, D, 4 options are given. It is a multiple select question, multiple, what do you call that? So more than one option can be correct, okay? Have you noted down this question? Have you taken a screenshot? Then we will stop for today. We'll discuss this tomorrow. Very easy question. I know that you will be able to solve this, okay? I am very sure that you will be able to solve this question. Yeah, Bhavya, wait. Let's leave it for tomorrow, okay? Just give me the answer tomorrow, okay? Okay, then I am going to stop, right? And I will see you tomorrow. We will discuss this question and we will start entropy, okay? We'll start entropy. Some good questions we are going to solve. And if you please, what you can do is you can note down your doubts as well, okay, for entropy. If you have any doubts, you can ask them tomorrow. Other than some like doubts that you have, other than the questions that we are going to solve, you will get some doubt from there, it's okay. But if you have some other doubts also, like in general with entropy, because a lot of people have doubts, okay, so you can ask them tomorrow. Thank you, Tarun. I think Tarun was right. Thank you, Tarun. So you can ask that tomorrow as well. Also, please follow the entropy sessions that I have done. I hope that you will find them useful. Okay. Okay. So we are going to stop now and I will see you tomorrow at the same time, 6 p.m. Okay. We'll start entropy. Thank you very much.